Hi, and welcome to Lesson 2.6. This is our last chapter on proof, at least our last chapter on learning how to use proof. Today we're actually going to be doing some geometric proofs about angles. So we'll use some of the information that we've learned previously about angle pairs, and we will see how we can show step by step in a logical fashion, always using evidence to back up our claims, why some of these things have to be true. And we're going to begin with the theorem or a theorem about vertical angles. See, we've accepted this all the way through. You believed me when I told you that vertical angles are congruent. Today we're going to prove that this has to be the case, and we're going to prove it deductively, which means that it can't be disputed, not just by looking at some angles, but instead by looking at facts. So the statement of what we're to prove are that vertical angles are congruent. The first step in our proof-solving plan was to write that in if-then form so we can tell what's really given and what we have to prove. So I believe that a good way to write this in the if-then form, in conditional form, is this. If two angles are vertical, then they are congruent. If two angles are vertical, then they are congruent. All right, and we already have a diagram. I'm going to choose angles 1 and 3 to work with. They do fit the definition of vertical angles. They're right across from each other when two lines cross. So I'm going to say that angles 1 and angle 3 are vertical. And our job then, okay, starting with vertical angles, is to prove they are congruent. So we want to end up by saying that angle 1 is congruent to angle 3. Now, I think that we've talked through this before. I really believe that you should always make a plan before you ever start writing a proof. You should think through why you think it has to be what you think. So, as we look at this, I believe we've said before, see how that line right there, those two angles, angle 1 and 2, make up that line. Together, angles 1 and 2 have to add up to 180. As you add the measures of the two smaller parts, it has to be equal to the measure of the greater angle. That's the angle addition postulate. That's true about angles 1 and 2. And I'm going to just draw in here a little bit. It's also true about angles 2 and 3. The outside edges of angles 2 and 3 also form that straight line. So that must be 180 degrees. And you can see right away that the measure of angle 2 is inside both of those angles. Well, if we were to subtract out angle 2, that would leave us with angles 1 and 3 having to be equal. Okay? That's going to be our plan. We're going to use angle addition, the fact that the sum of the two angles have to be equal to each other. Then we will subtract out the common angle, angle 2, and then we'll be right where we want to be, saying that angles 1 and 3 have to be congruent. So let's see how that plan works out in our proof. We begin with the fact that angles 1 and 3 are vertical angles. So angle 1 and 3 are vertical. We know this because they told us. That's the given information. Now where we have to go next is showing that the angles 1 and 2 together form that linear pair, like the bigger angle there. So that's where I want to start here. The measure of angle 1 plus the measure of angle 2. And I've said that they're forming a line, right, or a linear pair. Well, linear pairs always measure 180 degrees. So the measure of angle 1 plus the measure of angle 2 is 180 degrees. That's also true about the measure of angle 2 plus the measure of angle 3. And y'all, I'm using the same reason for both of those statements, so I'm only going to write it once. But you could call that either angle addition or linear pair. I would accept either of those as being correct reasons for that statement. Now I'm looking at this thinking, okay, I have two expressions here that both equal out to 180. So I could use substitution. Some folks would say that we're going to use the transitive property, and again, usually those can be interchanged, so I'll write them both. But if we have two things that both equal the same number, they must equal each other. Therefore, the measure of angle 1 plus the measure of angle 2, right there, has to be the same thing as measure of angle 2 plus measure of angle 3. Do you see how that substitution works there? We're saying if they both equal 180, then they have to equal each other. Alright, once I'm there, then this is not bad. I can see right away that I have that measure of angle 2 on both sides of this. So if I subtract out, or use the subtraction property, I can subtract away that measure of angle 2, and it's going to leave me this. Measure of angle 1 is equal to measure of angle 3. And boy, that's awfully close to where we want to go. We want to say they're congruent. Well, you know, I think once we're here, we really can say that, because the definition of congruent, so we're going to use a definition here. The definition of congruent angles, or just definition of congruence, says that when you have equal measure, you have congruence. So angle 1 must be congruent to angle 3. And folks, we have just proved our first theorem in geometry. A statement that can be proven deductively, such as we did, is called a theorem. We've spread that word around, but we haven't actually defined it. In fact, this one is important enough that it has a name, and this guy is called the vertical angles theorem. Vertical angles theorem. From now on, we know beyond a shadow of a doubt, without ever having to do this work again, because we've already done it, we've proved it, once and for all, vertical angles must be equal. So for now and from evermore, we know that if we see two angles that are vertical, they have to have the same measure. And that, folks, is the power of proof. Let's see how we can use that factoid next. This will be similar to problems that we had worked in our first chapter. We're going to use the vertical angle theorem. Notice that we have a set of vertical angles here right across from each other when two lines cross. And the theorem says that they have to be equal to each other. So it must be true that 6x plus 16 has to be exactly the same thing as 136, has to be equal to. Solving for x would mean subtracting 16 from both sides, and we know the algebra to this. 6x will equal, let's see, that's going to be 120, and to find our value for x, we divide both of our sides by 6. X would be, well, 6 goes into 12 twice, and there's a 0 left over, so x would be 20. We used the vertical angle theorem, so we'll see some problems like that in class tomorrow as well. We basically have several theorems that we're going to walk through in today's time. So we're going to use a very similar technique to prove Theorem 2.2. This is the way our book numbers them. Chapter 2, Theorem 2. The congruent supplements theorem, it's called. If you read the language of this theorem, if two angles are supplements of the same angle, or it says of congruent angles, then the two angles are congruent. So we have two angles here, 2 and 3, that are supposed to be supplements of the same angle, angle 1. And the theorem says if they both are supplementary to angle 1, then they have to equal each other. That's what we're going to try and prove. I've written the given and prove here. Angle 1 is supplementary to angle 2, so these two together, what does it mean to be supplementary? They add up to 180. It's also true that angles 1 and 3 together add up to 180. And if that's the case, this theorem says we should be able to show that angle 2 here and angle 3 are congruent. Now, my claim is that this theorem is going to prove a lot like the last one. So I'm going to go ahead and draw my T here. And I'm going to have statements on my left, reasons on my right. And I'm going to begin with the given information. I'm going to try and write it small, though. I try to abbreviate if I can. Angle 1 is supplementary, so is sup to angle 2 and to angle 3. And that's our given information. All right, if that is the case, then I think we want to talk about what it means to be supplementary. See, we've already kind of sort of went through this. Two angles that are supplementary add up to 180. So by the definition of supplementary angles, here's what we can say. The measure of angle 1 plus the measure of angle 2 equals 180. At the same time, if angle 1 is supplementary to angle 3, we can go here. The measure of angle 1 plus the measure of angle 3 also have to be 180. And notice again, those two statements use the same reason. I'm only going to write that reason one time. Now, if you think back to our last one, you're going to be thinking ahead because you're going to say, yeah, hey, there's two things that both equal 180. These two parts must equal each other, and that's exactly the case. The measure of angle 1 plus the measure of angle 2 has to be the same thing as the measure of angle 1 plus the measure of angle 3. That's a substitution, folks, or transitive property, although I like substitution better in this particular case. I will write both. You only have to write one. Transitive. Okay, our textbook tends to use those interchangeably. Well, I can see that I have the measure of angle 1 on both of those sides. So if I subtract that out, very similar to what I did before in the last proof, use the subtraction property to subtract the measure of angle 1, if you wanted a hint about what we're doing. That's going to leave us, after we do that subtraction, with the measure of angle 2 equaling the measure of angle 3. And that doesn't quite say that they're congruent, but it's very close. If they have the same measure, then the definition of congruent angles says that they have to be congruent to each other. Some folks, definition of congruence is that last reason. Some folks would stop here. Technically, we shouldn't. Our to prove statement said that we needed to get to angle 2 congruent to angle 3. So that really should be the last reason that we write in this proof. And we've seen two now that used very similar logic. I want to push on real quickly here and tell you that the next theorem that we talk about, the congruent complements theorem, we're not going to prove in this lesson. However, it is part of the assignment we'll be working on tomorrow. And this one is very similar. It says, if two angles are complementary to the same angle, if two angles are complementary to the same angle, or just like in the previous theorem, or two congruent angles, then the two angles, actually I should probably say the first two angles, are congruent. That is very similar to the congruent supplements theorem. It's just that complementary angles add up to how much? It's not 180, 90. So tomorrow in class we'll be writing a very similar proof to two that we've done today. We have two more that we're going to look at today, and these are going to be our final proofs about angles today. In this one, we started the setup for this previously. This theorem says that all right angles are congruent. All right angles are congruent. And if you think about that, folks, they kind of have to be. They all measure 90 degrees, and angles that have the same measure have to be congruent. So our plan for this is to just say they all measure all right angles, they all measure 90 degrees. So they must be congruent. I won't always write the plan out, but I'll always talk through the plan. Let's see, we should write this in if-then form. If two angles are right angles, then they are congruent. All right, and we're going to start with what we pictured, that angle 1 and angle 2 are right angles. And what we want to show is that they have to be congruent. We always start with given information. And what we're given here is that angles 1 and 2 are right angles. Already, I know there's somebody out there that's saying, man, why do we have to write that again? We already wrote it up here. And I'll say, yeah, I know, but we're trying to model good proof writing behavior here. So angles 1 and 2 are right angles. We know that because they're given. If that's the case, folks, by definition, see, sometimes people are confused about when you're using a definition. But I'm going to say that those angles both measure 90 degrees. And folks, that is the definition of right angle. Right? We said that they were right angles. So by definition, they each measure 90 degrees. Well, if that's the case, look at what we have. We've seen this already today. We have two things that are equal to the same thing. So by the transitive property or substitution, okay, both are correct. It must be true that the measure of angle 1 equals the measure of angle 2. And that's good news for us, because we know that when things measure the same, that's what it means to be congruent. Or we can apply the definition of congruency. And I'll just stop right here and say, when you see yourself moving from an equal sign to a congruent sign, that's a definition. You're applying that definition of congruency, or vice versa. If you see yourself going from congruency to equals, you're applying the definition of congruency. And ladies and gentlemen, I don't know if you noticed, but we just proved that all right angles are congruent. Okay? Nice little proof about right angles. And we have one more in today's lesson. This one says, if two angles are congruent and supplementary. So congruent, we know that that means that they're equal. Supplementary means they add up to 180. So we're kind of working a plan right now. If two angles are going to be both equal and add up to 180, then each must be a right angle. If you think about that, that's true. If they add up to 180 and they're equal, that means that 2 times whatever equals 180, and the whatever has to be 90 degrees. They have to be right angles. So you can think this through in your head. What we want you to think about is how to write out the given information, what is it that we're supposed to prove, and then make a diagram that illustrates that. So will you pause the video right now and do those things? What is it exactly that we're given? What is it that we have to prove? And it might be helpful to make that diagram first. Now I'm going to draw a special case of this, but it will be a good case. I know that a straight line has 180 degrees. So I'm going to show a straight line right here. And two angles, 1 and 2, that according to the statement have to be congruent. So they have to have like arc mark here, because angle 1 is equal to angle 2. They have to add up to 180, and I covered that with my line there. The thing is then, the given information is that angle 1 is congruent to angle 2. Also, angle 1 and angle 2 are supplementary. What we have to prove then is that angle 1 and angle 2 are right angles. And now it's time for us to actually sketch out our proof. I think the diagram is going to be our best friend here. It says in the instruction for this that if you wanted to write this in paragraph form, you certainly could. You know, 2-column isn't the only way to write a proof. It's just a good way when we're learning, because again, it makes us organize our thinking. So I am going to go ahead and show this in 2-column format. Let's see. My plan was together they add up to 180. And they have to equal each other. So this is the same as this. So I could just say 2 angle 1's right here. two angle 1s have to add up to 180. Well, if I divide by 2, then angle 1 must be 90. And I know already that 1 and 2 are equal. So I think I just walked through that proof right in my head, and I'm hoping that that's what we'll do every time we plan to write a proof. Let's see if we can get it down on paper here. Angles 1 and 2 are congruent. We know this. And we also know that they are supplementary. So angle 1 and angle 2 are supplementary. And I will always abbreviate because I want to try and fit it all on one line. So, okay. Let's go with the supplementary thing. Okay, I think that's where we want to go if two angles are supplementary. So, based on this factoid, we can say that the measure of angle 1 plus the measure of angle 2 equal 180 degrees. Why? Because that's what it means to be supplementary, or that's the definition of supplementary angles. When you hear yourself saying that's what it means to be, you're applying a definition, okay? We've used the supplementary part of this, but really we haven't quite used the congruent part. If two angles are congruent, their measures are equal. So we can say that the measure of angle 1 is equal to the measure of angle 2. We've gone from a congruence to an equals. That means we've applied the definition of congruence here. Now, let's see. If the measure of 1 is the same as 2, we could substitute, correct? So we could say that the measure of angle 1, well, twice, because we're putting it in here, so 2 times the measure of angle 1 is equal to 180. Folks, that's a direct substitution. What we did is just said, okay, we already know that angles 1 and 2 are the same, so where this said angle 2, I'm putting in an angle 1, and that gives me 2 of them. One angle 1 here, plus another one here. So 2 measure of angle 1s equal 180. Well, I think I can divide both sides by the same value, right? That's the division property. Let's see, division property. So if I divide by 2, then the measure of angle 1 is equal to 90. And guess what? I know that the measure of angle 1 is equal to the measure of angle 2, so it's also true that angle 2 equals 90. And that is a substitution that we're doing. And I'll tell you what, I think we have our proof right here, because if angles equal 90 degrees, then they are right angles. That's what it means to be a right angle. Or by the definition of right angle, angle 1 and angle 2 are right angles, because they measure 90, both of them do. And ladies and gentlemen, that's a pretty nifty proof right there. So we have 5 theorems about angles that we were able to prove today. By no means are we expecting you to be expert at this. We're all just learning it right now, but we've given you lots of good stuff to look at and think about. And in class tomorrow, we'll continue talking about how to write good proofs. So have a good evening. Try that you try.